Hello students, welcome back. So here we are with another lesson on rational expressions. And I believe this would be notes number 45, and today we're going to add and subtract rational expressions. So go ahead and get yourself ready for notes. And we are going to do, I believe, 4 examples today after going through this first slide on fractions. So what we want to do before we add and subtract rational expressions is remember how we add and subtract rational numbers. So how do we add fractions? So let's take a look at the first one. Remember that to add and subtract fractions, you need to have a common denominator. And if you have a common denominator, all you need to do is add or subtract the numerators. So we have a common denominator on the first one, and all we need to do is add the 3 and the 5, and we get 8/11ths. Let's take a look at the second one. We don't have a common denominator. We need a common denominator. So what we do is we find a way to get a common denominator. And you know that you can take a fraction and you can maintain its value, even though you change how it looks, you can maintain its value if you multiply it by 1. So we want to multiply each of these fractions by a special form of 1 that will maintain its value but make it look different. And so we end up multiplying the first fraction by 7/7 and the second fraction by 4/4. Why 7/7 and why 4/4? That's because we're trying to get a common denominator, and it makes sense that we're going for 28, because 28 is the least common multiple of 7 and 4. So this gives us 21/28 plus 20/28, and add those together and we get 41/28. It's fine to have an improper fraction. You do not need to change it to a mixed number, but if it could reduce, you would reduce it. Okay, let's take a look at the third one. So once again, we do not yet have a common denominator, but we want a common denominator, and so we want to find the least common multiple of the denominators. Now, you could use any common multiple of the denominators. You could just take 8 times 14 and use that. That would be 112. You could use that. It would work just fine, but you'll make it easier on yourself if you use the least common multiple of the denominators, and we're going to call that the least common denominator, LCD. So how do you find the least common denominator? You need to know the factors of the denominators. So looking at the first denominator, 8, that would be 2 times 2 times 2. Looking at the second denominator, sorry, I'm going to redo that. My tools aren't the greatest. 2 times 2 times 2. Okay, looking at the second denominator, you could factor that into 2 times 7. So our least common denominator is going to have a 2 because they both need it. It's going to have another 2 because one of them needs it. It's going to have another 2 because one of them needs it. And it's going to have a 7 because one of them needs it. So that's going to be 8 times 7, 56. So our least common denominator is going to be 56. So then you ask yourself, what do I need to multiply my first fraction by in order to get 56 as my denominator? That would be 7. So this one gets multiplied by 7/7. And then you ask yourself, what do I need to multiply my second fraction by so that it will have a denominator of 56? And that would be 4. So we multiply the second fraction by 4/4. Okay, so that gives us 21/56 plus 8/56, and you add those together and you get 29/56. And then if you could reduce that, you would. So that's the concept, and we want to apply that concept to rational expressions. Now, what about subtracting? All the same concepts apply. You're just subtracting instead of adding, so no need to go over that in any special way. All right, here's example number 1. Notice that we have common denominators already. That's great. All we need to do then is add the numerators, and we get 14/5x. Easy peasy, it doesn't reduce. That's it. Let's take a look at number 2. We do not currently have common denominators, so we want to find our least common denominator. So let's go ahead and factor our denominators and then find the least common multiple of those factors. So I'm going to factor 10x squared into 2 times 5 times x times x. And I'm going to factor 5x squared minus 10x. I'm going to pull a 5x out of both terms, the greatest common factor. 5 times x times the quantity x minus 2. So what is our least common denominator going to be? Well, it's going to need a 2 because one of them needs a 2. It's going to need a 5 because both of them need a 5. It's going to need an x because both of them need an x. It's going to need another x because one of them needs another x. And it's going to need an x minus 2 because one of them needs an x minus 2. Okay, so then you ask yourself, what do I need to multiply the first fraction by so that I will have that least common denominator? It already has a 2, it has a 5, it has an x, it has an x. It doesn't have an x minus 2. So we're going to have to multiply the first one by x minus 2 over x minus 2. Now you ask yourself, what do I need to multiply the second fraction by so that it will have the least common denominator? It already has a 5, it already has an x, it already has an x minus 2. It doesn't have a 2 and it doesn't have an extra x. So we need to multiply it by 2x over 2x. All right, now what do we have? The first fraction is 3 times x minus 2 over the common denominator. We could write it out as 10x squared times x minus 2 minus the second fraction is 4x squared over 10x squared times x minus 2. And remember, our goal is to subtract these, so let's go ahead and subtract the numerators. And at the same time, I'm going to distribute the 3. So my numerator is going to be 3x minus 6 minus 4x squared over 10x squared times x minus 2. Now here's the thing. Remember, once you get your answer, you need to reduce it. Does this reduce? I don't know yet. I don't know until I factor the numerator to see if it has any common factors with the denominator. So let's rearrange the terms in the numerator into a more factoring friendly order. And then let's see if that factors. I'm going to pause and work on that, and you can do the same thing, and we'll come back together and see what we come up with. All right, I found that this does not factor. And do you know what I did? Do you remember the discriminant? B squared minus 4ac from back when we were doing the quadratic formula. Remember how the discriminant would have to be a positive perfect square in order to tell you that the expression is factorable? So the discriminant would be 9 minus 4 times negative 4 times negative 6. And that would be 9 minus, oh, what's that, 96? Okay, not a perfect square, not factorable. But it's important to check because sometimes they might be, and sometimes these answers can reduce. So here's our answer. Okay, let's move on to the next one. So here's number 3. Take a look at these denominators, and hopefully you recognize what's going on here from our last couple of lessons. X minus 3 and 3 minus x are what? It rhymes with opposites, if you need a hint. They're opposites. So how could we get the same denominator? Well, we could take one or the other fraction, whichever one we like, and multiply it by negative 1 over negative 1. So I'm just choosing to multiply the second one by negative 1 over negative 1. So now my first fraction is still 2x over x minus 3. And my second fraction is negative 1 times x minus 1 over, what is the new denominator going to be? It's going to be x minus 3. Now I could have also simplified the numerator at that point. I'll do that now. So 2x over x minus 3 plus 1 minus x over x minus 3. Okay, we have a common denominator. We can go ahead and add these numerators together. 2x plus 1 minus x is going to be x plus 1, and that's over x minus 3. Okay, problem number 4. Back to having unlike denominators, so we're going to factor these denominators and figure out what the least common denominator needs to be. So factor the first one into 3 times x minus 5, and let's see what we can do with the second one. Okay, just discovered that I made a mistake typing this up. I bet you're relieved at that. So there's not supposed to be a 5 on there. Let's scribble that out. It's just x squared. That's going to work out a lot better. Okay, so we're factoring that denominator into x minus 5 times x plus 1. All right, so now we're figuring out our least common denominator. So we're going to need a factor of 3 because one denominator has it. We're going to need an x minus 5 because they both have it. And we're going to need an x plus 1 because one denominator has it. So that means we need to multiply our first fraction by x plus 1 over x plus 1, since that's the factor it didn't have. And we need to multiply our second fraction by 3 over 3, since that's the factor it didn't have. So now what do we have? The first one is x times x plus 1. Now I'm just going to go ahead right now and combine these into one fraction. So then the next numerator is minus 3 times the quantity 2x plus 2 over the common denominator 3 times x minus 5 times x plus 1. Now we need to simplify the numerator. So we'll distribute the x squared plus x, and we'll distribute the negative 3. Now this is a place where so many people mess up. They forget about the negative. So just be real careful with the signs. We would have minus 6x minus 6 over our common denominator. Let's combine the like terms. So we have x squared minus 5x minus 6 over 3 times x minus 5 times x plus 1. Now maybe we're done, but maybe not. We don't know because we have not yet factored the numerator. Maybe it's going to reduce with the denominator. Let's check it out. Does that numerator factor? That would be x minus 6 times x plus 1, right? Well, it does. So we could write it that way. X minus 6 times x plus 1 over, ooh, there is a common factor, over 3 times x minus 5 times x plus 1. Cancel those common factors of x plus 1, and what we have left is x minus 6 over 3 times x minus 5. Remember, you can distribute the 3 in your denominator if you want to, but you can leave it factored if you want to. It's perfectly fine either way. Great. Okay, so here is the assignment for today. Section 8.5, always show your work. Check your answers. See Google Classroom for the problems and the answers if you don't have access to the book. Notice I did give you an even, so you're going to need to check your answer for that one using Google Classroom. And always let me know if you have questions. Thanks a lot, everybody.